Hello everyone. So today we're going to go over a Chapter 2 review assignment that I gave everyone. So here are the questions here, and let's go through it. So number 1, an elevator in a high-rise building moves upward, keyword, at a constant rate. The table shows the height of an elevator above ground at various times. Okay? So let's just go through it. So if you can see from here to here, it's 1 second, right? From 1 to 2 is 1 second. You get the idea? And then it goes up 0, 12, 12 to 24 is another 12. So I'm going to assume that's going to jump probably another 12. So at 1 second is 12, 2 seconds is 24, 3 seconds, it's 36. And I'm going to jump to 5 seconds. 5 seconds is going to be 60 because it's going up by 12, so 5 times 12 is 60. So 4.5. So if it's jumping from 12, 12, 12, 12 at 4 seconds, it would have been what? If you add 12 to 36, 48, right? So if there was a 4 seconds, it'd be 48. Now, 4.5 is halfway between 4 and 5. So if 4 gives us 48, 5 gives us 60, what's halfway between 48 and 60? It's going to be 54. Because 4.5 is halfway between 4 and 5. 54 is halfway between 48 and 60. Now we need to find an expression. So I'm going to assume that, since I probably shouldn't assume anything. You know what they say about that, but anyway. It's going up by 12, right? As you guys see here. Okay? So 12 times 1 is 12. 12 times 2 is 24. 12 times 3 is 36. And you get the idea. Alright. What are the dependent and independent quantities in this problem situation? Explain your reasoning. Independent and dependent, usually the quote-unquote x and y. It's right here. Independent, dependent. So, independent is time. Dependent is height. And what unit measurement would they be? Like, time would be measured in seconds. Height, probably feet. Okay? Moving on. Determine the unit rate of change for the problem situation. So the unit rate of change, that's like miles per hour, gallons per meter, or something along those lines. I'm going to say this is going to be feet per second. Because it's going to go 2 feet, or 12 actually, height. It'll go 12 feet in 1 second. 24 feet in 2 seconds. Alright? So it's feet per second. Complete the table. Write an expression that represents the height for an arbitrary time t in the last row. See table. Alright? Letter D. Use function notation to determine the height of the elevator at a time of 14 seconds. So, keyword, function notation. That's usually where that you write f of x, or if it's independent of time, f of t. In this case, it's time. So we're going to do that. F of t equals, well, we did that already. We already wrote that expression right here. 12t. Let's just fill it in. F of t equals 12t. Now, determine the height of the elevator at a time of 14 seconds. So what they're asking is, see how this table keeps going at seconds 0, 1, 2, 3, 4, 5. So they want to know when seconds is at 14, what's the height going to be at in feet? So in theory, yeah, you can just count 6, count 7, but that takes forever. So since we already have an expression for it, we're just going to do it the easy way. Let's plug in t equals 14. Okay, so we plug at time 14 seconds into the function. F of 14 is 12 times 14. And no, I haven't done it yet. Okay, do it 8, 4. $168. And to write it the nice way, f of 14 equals 168. And there's your answer. Okay? Let's see. What's next? Number 2, solve the equation and justify your reasoning. All right? Not too hard. So anytime you see parentheses, like you do here, that's the distributive property. So 5 times x is 5x plus 5 times 4 is 20 minus 8, and just bring everything down. Oops, you don't bring that down. X plus 32. Combine like terms. 5x, 20 minus 8 is 12. Bring everything down. Now, when I say combine like terms, a common question is, well, which ones are like? Which ones are not like? So, basically, I'm combining all of the numbers together. So, 28 and 32, I'm going to combine together. And I'm going to combine all of the variables with the coefficients. So I'm going to combine the 5x and the x. And what you want to do is you want to get all of the variables on one side of the equation, all of the numbers on another side of the equation. So currently, we're even, right? We currently have a variable and a number, a variable and a number. So it really doesn't matter which one you move around first. You can put the 5x on the right side. You can put the x on the left side. Doesn't matter. I always like to work the small numbers first. So I'm going to go ahead and just subtract 12 to both sides. 5x equals x plus 20. Okay, so we have the number 20 right here. It's on the right side, and that's the only one there is of a single term. So let's go ahead, but we have x's on both sides, left and right. So let's go ahead and get rid of this x, so it evens out. Subtract x to both sides. Now I'm going to move up here. 4x equals 20. And then opposite of multiplication is division. We're going to divide by 4. X equals 5. Okay. Now when it says justify, I think justifying is just plug it in and check it. That's justification enough for me. Let's just do check. And we'll plug it into the original equation. 5x plus 4 minus 8 equals x plus 32. Plug 5 in for x. 5. Everywhere there's an x, you're going to plug in 5 because that's what we have here. 5 plus 4 minus 8 equals 5 plus 32. All right. Let's do parentheses first. 5 plus 4 is 9. And what's 5 plus 32? 37. 5 times 9 is 45. Minus 8. I don't know. And 45 minus 8 is 37. Yep. So that's how you know if the left side equals the right side when you plug in your value for x, which was this guy right here. When you plug it in, if they equal each other and it's a true statement, then you're good. If they don't equal each other, if you get something like 5 equals 100, then that's definitely wrong. Then your answer is wrong. All right? I think that would answer that one pretty good. Number 3. Suppose an elevator starts at the top floor of a high-rise building at a height of 372 feet above the ground and descends. Descends means what? Down, to go down, without stopping at a constant rate of 15 feet per second. So they give us everything. Write a function that describes the height h of the elevator after t seconds. So, let's see. Remember I said write a function that was the f of x, f of t in our case. So this says that describes the height h of the elevator after t seconds. So I'm going to go ahead and do h of t. This way we covered the h and we covered the t. Equals, we start at 372 feet. And we're descending at a constant rate of 15 feet per second. So is that addition or subtraction? It is subtraction. So we're going to go down and we're going to subtract 15 feet per second. And the variable has to go somewhere, right? I don't think it's going to go as 372. I would say it goes at 15 because at 1 second you went down 15 feet. 2 seconds you went down 30 feet. 3 seconds, you get me? So let's do t. And there's your function. Done. Graph the function that you wrote in part A. All right, let's do it. So I'm going to call this 0. Okay. 1, 2, 3, 4, 5, 6. You can go further if you want. Now, instead of marking every single little hash by like 2s or 1, forget all that. I'm going to do this. I'm going to start at 372. And let's just say 372 is right here. Okay? Now, at 1 second, if you plug 1 in for t, you're going to get 372 minus 15 times 1. 372 minus 15 equals, no idea. Let me see, 372, 367, 357. So that would be right here. And 15 minus 357 is 52, 342. 15 minus that is 37, 27. And then 15 minus that is going to be, what? 312. Alright, hopefully you guys get my idea. All I'm really doing is I got this number, subtract 15. Let me do a different ink. I did minus 15. From here to here, minus 15. From here to here, minus 15. From here to here, minus 15. And you can continue with this process. But the reason I did that is, remember, the function says we start at 372. And we're going down every second. So every 1 second, we're going down at a rate of 15. So at every 1 second, I'm just taking 15 off. So this is how it's going to work. At 0 seconds, we started at the top. 1 second, we started here. I already took the 15 off on the left-hand side. At 2 seconds, we're here. 3 seconds. And it makes it easy doing it this way. 4 seconds. You get what I'm doing? And I can let you finish the rest. And you just draw a nice line. Hopefully yours is nicer than mine. And that's it. There's your graph. Okay? Hopefully I explained it good enough. But you just keep subtracting 15. Okay? I'll do one more. 3, not 3, probably 2. 297. Alright, and you get it. So moving on. Ooh, there's more. Estimate when the elevator is at height of 200 feet. Okay, so what was our function again? Our function was h of t equals 372. Yeah. 372 minus 15t. Now they want to know when the elevator is at a height of 200 feet. So we're not going to plug it in for time, but we're going to set it equal to. So let's go ahead and do that. 200 equals 372 minus 15t. Now we're going to solve for t, because if we solve for t when h of t is 200, then that'll tell us exactly at what time will it be 200 feet. So let's subtract 372 to both sides. And move all this. Okay. You're going to get negative 172 equals negative 15t. Go ahead and divide by negative 15. And our answer is going to be positive, okay? Because negative divided by negative is a positive. And the problem is, how does 15 go into 172? 15 goes into 17 once. You get 22. 15 goes into 22 once. And you get, that was 22. 5, 6, 7. Point, add a 0. 15 goes into 70. 15 times 4 is 60. Add another 0. And you know what? I'm going to leave it at 11.4. Good enough. Probably keep going. So 11.4 seconds is t. Okay? Let me erase this. Alright, so what this is saying is that at 11.4 seconds, the elevator will be at a height of 200 feet. And you notice how we got a decimal, 11.4? That's why they said estimate. So take a good guess. Alright, so that's letter C. Determine the exact time that the elevator is at 200 feet? Well, if we know at an estimation, it'll be 200 feet at, oh, this is easy. So this is where they try to trick you. So this is an estimation, right? At t equals 11.4 seconds. It's going to be 200 feet. Determine the exact time that the elevator will reach there. So we know it's going to be 200 feet. It's going to be a decimal regardless, right? When it hits 200 feet, it'll be 11.468, whatever. It's going to be a decimal. Okay? So either I didn't go far enough, and it's going to be a bigger number, 11.48 something, and it'll end. Or, and I'll let you guys check this one out, or the exact time when it'll be is up here. Now change ink. The exact time will be at 172 over 15. And yes, you don't say, oh yeah, at 172 over 15, that time it'll be 200 feet, but that's an exact answer. Okay? This is an approximation. This is just a really good guess. This is an exact answer. So, I'll let you check this one out. And if it does give you an exact decimal, like 11.4829, I guess you can do that. Or you can just do this. Okay? I would just do this. Moving on. All right. Evaluate the function f of x equals 31.572x minus 17.741 at each value. These are easy, and I'll let you do these. You have a function here. All you do is plug it in. So f of 6.2, there's an x right here, right? But when you look here, there's a 6.2. So everywhere there's an x, you plug in a 6.2. Equals 31.572 times 6.2 minus 17.741. Do the math, get a number. Pretty easy. And you're going to do the same thing over here. F of negative 27.018 equals, again, 31.572 times negative 27.018 minus 17.741. Do the math, get a number. Okay, these are easy. These are what's called plug and chug. All right. Solve the inequality and graph the solution on a number line. All right, just like I told you guys before, when you see these parentheses, distribute. So this is negative 4 times x, negative 4 times 1. So negative 4x. Negative 4 times 1 will be negative 4, greater than or equal to 12. And again, just go ahead and solve it. Add 4 to both sides. Negative 4x greater than or equal to 16. Divide by negative 4. Divide by negative 4. And when you divide by negative, what do you do to the sign? Flip it. So x flip greater than or equal to negative 4. All right, so when we graph it, no, you don't have to put all the numbers. Just put 0, 1, 2, 3, 4. This looks like negative 4. Is that an open, open or closed circle? It's a closed circle. It says x is less than, see right here? X is less than negative 4. So all values of x that are less than negative 4, which would be negative 5, of course, and then negative 10, and so forth. So we're going to go that way. Okay? Next one. Graph the compound inequality on the number line. So let's just do it. X less than 4, open or close circle. Close circle. And it says x is less than 4. So 3 is less than 4, 2 is less than 4, 1 is less than 4. It's going that way. And then x greater than equal to negative 1. And that's a closed circle at negative 1. X greater than. So 1 is greater than negative 1. 2 is greater than negative 1. 3 is greater than negative 1. So it's going to go that way. All right. Pretty easy. And we end with absolute values. Yes. Okay. So let's go ahead and do these. Absolute value of 4 minus 12. Well, go ahead and do the absolute value first. So think of it. I don't want to say think of it like parentheses, but when I was growing up, that's how I used to do them. I used to think as if they were parentheses. So 4 minus 12 is negative 8. Absolute value sign still there. And the absolute value of negative 8 is 8. Okay, because absolute value is distance, and distance is always positive. And I talked about that in a previous video. Letter B. Negative 8 times 7 is negative 63. Is it negative? No, I think it's 56. My bad. 8 times 8 is 64. 56, yeah. Negative 56. And the absolute value of negative 56, again, distance is always positive, is just 56. Absolute value equation. I'm going to rewrite it. And these are the ones we break up. One of them we keep the same. 2x minus 5 equals 7. And the other one we change. 2x minus 5 equals negative 7. All right? So once we break it up, we get rid of the absolute value signs. Or absolute value bars. I don't know. So let's go ahead and solve the one on the left first. Just going to isolate the variable, so add 5 to both sides. 2x equals 12. Divide by 2, divide by 2. Bam. X equals 6. The other one, other side. Add 5, just like you did in the previous example. Add 5. 2x equals... So people always struggle with the negatives. So you have negative 7 plus 5. So that's like if somebody owes you $7, right? You're negative $7 in the hole. And they say, hey, you know what? I only got $5. They give you $5. How much do they still owe you? They owed you 7 and they only paid you 5. They still owe you $2. So you're still negative $2. Again, that's how I used to think of it when I was growing up. Now we go ahead and divide by 2. Divide by 2. X equals 2 divided by 2 is 1. But since there's a negative, 1 negative is just negative 1. And there you go. Done, son. Awesome. So I hope this video was helpful. Again, if you have any questions, comments, concerns, or I messed up somewhere, please go ahead, contact me or leave a comment, and I'll address it. All right, guys. Catch you next time. Peace.